The focus of our project was to develop a robust peer-to-peer system for efficient and reliable file storage and retrieval. We aimed to devise a solution to handle splitting uploaded files into parts to be encrypted and distributed across multiple nodes in a network, while also conceiving a way to correctly recollect file parts from peers in order to merge parts and retrieve the file.
To split the files, we split them into 4 kilobyte chunks, and then hash a combination of the unique user ID, the file name, and the file contents to ensure there's no clashes in the network. And for each file chunk, and then each file chunk is then uploaded to the network. Furthermore, a file is created that holds all the unique hashes for the file chunks in a manifest file, and along with the file chunk name, that is also uploaded to the network on its own unique hash of the same kind, and then the user or the client itself saves the file hash to so it can find the manifest file on the network, which Dylan will now talk about.
Yeah, so each node is running the Kademlia protocol, which is our DHT. The DHT will use consistent hashing and evenly distribute these file chunks throughout the network, and it'll send multiple copies for redundancy as well.
To retrieve the file, using the client list of all the files uploaded, shown here, it will get the manifest file for all the file parts. Once it retrieves the manifest file, it will read the hashes in the manifest file to ask the network for the file chunks, download all of those, and then put it together again, shown as such. It looks squished. That is my window manager, I assure you.
So kind of just as Laurence, Juhani, and Dylan explained, this is just a distributed file storage system, and the UI boots with every node service that comes up. So any node service that comes online comes with the UI, so that the users can upload their files to the network. As Juhani has shown, he uploaded a image. You can upload multiple file types. You can upload text files, various types of image files. Juhani's going to upload a text file here.
No, I'm not.
Oh.
There is a specific error with our software that doesn't find certain files if they have the wrong permissions, which is unfortunately something we have not yet fixed.
Can you create a text file?
I'm sure I can find a text file somewhere. What if I upload from one further? There we go. You can also see in each of these on the top, it shows all the information coming in. So this is uploaded. It's working on uploading the text file I've sent. As you can see here, it got a store request for that.
So now it's uploaded. You can retrieve it and preview it.
Retrieve file.
And you can see the text that was inside. Other kind of notable features that the users can do is they can see discoverable nodes. They're well-known nodes or bootstrap nodes that are known to the centralized server. You can see the port number displayed in the top of the current service that's running, and you can refresh your files list, though the files and the discoverable nodes update every 10 seconds or so. This keeps you well informed with what's going on with your files in the system. I think Dylan will talk about the centralized server.
Yeah, so how it actually works, how it has those list of discoverable peers, each node each node is going to contact one of our central servers, which is used for onboarding the peers. They hold the list of discoverable nodes that they will pass to newcomers who want to join the network.
Seen on the bottom.
So on the bottom are all of our servers, and they run in a hierarchy. So how we currently have it set up, on the left of your screen is our primary, the middle is the second tier, and the far right will be the tertiary tier. The highest in the hierarchy is the one which is going to be treated as the primary at all times. So the nodes, when they want to look for peers so they can join the network, they will try contacting the servers in order of the hierarchy. Each server is going to keep a list of these discoverable peers, and it's passed to each other in a protocol that uses HTTP. It's called Flask. And they pass those back and forth, and they'll send 3 types of messages. It's to opt into the server, which is add a discoverable peer. It's to remove a peer, and a heartbeat message. And the heartbeat message also is sent by all the servers, and they contain a list of those discoverable nodes, so it's always up to date. And they're sent out every 5 seconds. So if you take one down, for example, Juhani, take the primary down, so the one on our left. So you'll see it should now start saying in the middle one and on the far right, no heartbeat detected, and it'll be down. And you can see the new you can see the HTTP request now going to the new primary because the nodes have realized that it's also down and they're trying the next one. If you now try to take down a node, the node that you take down will send a opt-out message to the server, to one of the central servers, and it will take it out of its discovery nodes and forward that to the other backup. So you'll notice both the middle and the right side have the discoverable peers set to 2. There's 2 IPs in there now because one node just went down and told itself to opt out. And that's
The distributed hash table, the peer-to-peer network, and the primary backup combination, we've built a redundant distributed file storage network.
Thank you all for watching. Enjoy your project.
Thank you.